Okay, so everybody, we've learned so far when solving a polynomial, we've learned how to factor by two different methods so far, right? So we've learned how to factor by grouping. So if there's four terms, we factor by grouping and then solve. And then second, we've learned how to factor out greatest common factor, continue factoring if possible, and then solve. A lot of you just aced that part of the test. It was awesome. I was very, very impressed. So let's go ahead and solve these by the methods we already know how to. These are the same ones on your worksheet. So one thing to fix is this on yours says plus, make it a minus, otherwise it doesn't factor by grouping. If it doesn't factor by grouping, we're going to learn later how to solve that anyways. It's just the hardest way possible. So we want to use grouping if possible. Fix this to negative right here, and then it will factor by grouping, and then you can solve it. So ready, set, go. I want you to solve polynomial 1, polynomial 2, and polynomial 3. So, focusing, let's go quick. So, everybody watch. A lot of you are still kind of solving these the way I wouldn't necessarily solve them myself. I would definitely factor by grouping because we have four terms. Pull out x squared. We should be able to go pretty quick through this. X minus 4. Then what should I pull out here? And then left is x minus 4. Our safe haven's the same, so it truly factored by grouping. So I'll pull out x minus 4. And then left is x squared minus 4, right? We factored it. Now we have a linear and a quadratic factor, so we can set each of those equal to 0 and solve. X minus 4 equals 0. X squared minus 4 equals 0. Solve for x. X equals what? 4. And then we would add 4, so we have x squared equals 4, square root. X is equal to. Way to not forget that. Now, I really, on this upcoming test, it's going to be a bunch of solving polynomials by the most appropriate method. You're always going to check. This one was degree 3. I should have 3 solutions, and I do, so I'm not missing anything. Next one. This one's not factoring by grouping. What method of factoring am I using here? Greatest common factor. See, she came to the early morning review. She did the back of the test. She aced the test. Pull out x squared. Divide by x squared. Divide by x squared. What's left in my parentheses? Okay, now everybody, a lot of you are still solving this one. By the way, I wouldn't necessarily solve it myself, because this is not attached to anything with a plus or minus. This is factoring. Factoring that is the same thing as writing it as x times x. And then we have x squared minus 3. So now can't I set each of these equal to 0 and solve? So we get x equals 0, x equals 0, and then x squared minus 3 equals 0. Solve for x. There's 2 of our solutions. Add 3, x squared equals 3. Next step. Way to go, you're not forgetting plus or minuses. Once again, degree 4, I should have 4 solutions, and I do. I could also write this as x equals 0 with a multiplicity of 2. Okay, let's do this one. What method? Is it grouping? No, because there's not 4 terms. Greatest common factor, pull out what? Pull out an x, so then write what you have left over, divide by x, divide by x, divide by x. 2x squared minus x minus 3 equals 0. You'd say I have a linear and a quadratic. That is not a quick way of solving a quadratic like it was here. So let's continue factoring the quadratic. What multiplies to be a times c and adds up to be b. Negative 3 times 2. Next thing to check, we're going to have a little bit more advanced problems in here. Am I going to be able to quick factor? No, so we're going to quickly drop and break. But that's why we spent an extra few days learning how to solve and factor good so that we could go quick through this. So we drop down 2x squared, drop down negative 3, break down the middle term as those 2 factors, but I'm going to put them strategically in the order I want. Order doesn't matter. So I'm putting plus 2x and then minus 3x. And then we factor by grouping, and then you guys should be way quick at this with me. Pull out 2x, left is x plus 1, pull out negative 3, left is x plus 1. I'm not going too fast, right? Because we've kind of spent time on this. Pull out x plus 1, right? We've just spent so much extra time on this. It divides out. Left is 2x minus 3. Now, what can I not forget? Originally, I pulled out an x. I got to write it. Now, I can solve, because I'm going to set each of those equal to 0. So we have x equals 0, x plus 1 equals 0, and 2x minus 3 equals 0. Solve for x. There's one solution. And then add 3, add 3. So we have 2x equals 3. Next step. And then once again, we better check, was the original polynomial degree 3? Look back at yours. Yours is on your paper. So we're good. We have them all. Awesome. Any questions? So those are methods we've already learned. Okay. Now, this piece is going to be tested on, and this is stuff you learned last year, but I want to re-go over it because a lot of teachers last year, they just teach you to memorize it, and so you've forgotten it. And I'm going to just teach you how to think about it so you don't have to memorize anything because we have enough to remember for the test as it is. So if I said to you, given a quadratic, we know it's going to have 2 solutions, correct? All quadratics have 2 solutions. Now if I said to you, given this quadratic, what kind of solutions are you going to have and how many? You'll always say, I'm going to have 2 solutions. But if I don't ask you to give me the actual solutions, I just want to know what kind of solutions are you going to have. You can use the discriminant to tell me. So if I don't want you to find the actual solutions, you get what I'm saying. I just want to know what kind of solutions are we dealing with. Then you could just use the discriminant. So everybody, when solving a quadratic, we can use the quadratic formula. We know we'll always have 2 solutions. Now understand, real solutions will cross the x-axis and imaginary solutions don't. So a quadratic that looks like this has 2 imaginary solutions, and a quadratic that looks like this has 2 real solutions. All good? Now, couple things to note. When solving by quadratic formula, we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This part under the square root is what's considered the discriminant. So write that down for yourself on your paper, right? See, there's a little spot where I've already kind of taken notes for you. This is the same thing you have written right here. So the discriminant is what is under the square root of the quadratic formula. So you should not have to memorize that because you know the quadratic formula, so you already know the discriminant. You'll say it's what's under the square root of the quadratic formula. X equals negative b plus or minus the square root of, and then you'll start b squared minus 4ac, and that is the discriminant. Okay, there you go. You can change your song. Okay, so why this is important, think about it. So the discriminant, I like to say, helps us discriminate against what kind of solutions we're going to have. Now, discriminate means like make assumptions, right? So based on what's under the square root, we know what kind of solutions we're going to have. So this is the kind of solutions you can get when solving a quadratic. 2 imaginary solutions. We see that happen all the time, don't we? Now, can't we get 2 rational real solutions? Now, what rational means is your answers can be written as fractions. So think about it. We do get sometimes when we solve quadratics, fractional answers, don't we? Those are called rational solutions. And they're real because if it's crossing at, for example, 5/4, it's crossing the x-axis, so that makes it real. Does that make sense, everybody? Then also when we solve a quadratic, we sometimes get irrational solutions. So that's when you have a decimal that cannot be written as a fraction. For example, the square root of 3. Type into your calculator square root of 3. Hit math, enter, enter. So you type into your calculator square root of 3, for example. Hit math, enter, enter. Doesn't it just put it back in a decimal? That's because it cannot be written as a fraction. That's a real solution that crosses the x-axis at a decimal that can't be written as a fraction. So that would be an irrational real solution. Making sense? Yeah. It's irrational. It's just a fraction. I mean, it's just a decimal that can't be written as a fraction. If it crosses the x-axis, meaning if it's not imaginary, it's going to cross the x-axis, so it's real. And then also, there are times when we get 1 real solution with a multiplicity of 2. If I get x equals 2 and x equals 2, wouldn't that be 1 real solution with a multiplicity of 2? Okay, now here are some examples of when we will get these things based on the discriminant, when we'll get those answers. So everybody look, here are some examples. So looking at this, let's pretend we went through a quadratic formula and solved, and we got this. Do you see how looking at this is my discriminant? My discriminant is 3. Okay, everybody? Now, isn't this the square root of 3? Can I break that down and pull it out? No. So these, we're going to have, when we have square root of 3, for example, that would be 2 irrational solutions, right? Square root of 3 is a decimal that cannot be written as a fraction, right? It doesn't break down. So if it still has a radical in it, it's considered irrational. Do you all understand? Yeah. So, Everybody look. When you have two irrational solutions, that's going to happen when your discriminant is positive and your square root can't break down or doesn't simplify. This is maybe where you should be writing this on your notes. So when the discriminant is positive and you cannot simplify the square root, that's going to give you two irrational solutions. So if my discriminant, for example, I'm going to change a different example. If my discriminant was 7, the square root of 7, does that break down? Can it be written as a fraction? No. So that would be two irrational solutions. So do you see how if the discriminant is a positive number that cannot be simplified under a radical, it's two irrational real solutions. Okay, let's look at another example. If you had solved all the way, which we're not going to solve all the way, but this is an example of solving all the way. If my discriminant is negative, how many solutions and what kind will we have? Yep, wouldn't I pull out a 9? So if your discriminant is negative, then you're going to have two imaginary solutions. So discriminant's negative, two imaginary solutions. And then, right here, notice I have -2 plus and minus the square root of 4. What is the square root of 4? 2. Now think about it. -2 plus 2 over 5 and -2 minus 2 over 5. Isn't this 0 over 5, which is 0? And what's -2 minus 2 over 5? Aren't those fractional solutions technically? So those are rational solutions. Rational means fractional solutions. Do you see? So if the square root breaks down evenly, we're going to have rational, and they're going to be real solutions. So you'd say if your discriminant is positive and the square root simplifies evenly, we're going to have two rational real solutions. Those are going to cross the x-axis it's going to cross the x-axis. That makes them real. And last but not least, if we have a discriminant 0, what is the square root of 0? 0. So we have technically here -2 plus and minus 0 over 5. Is taking 2 and adding 0 any different than taking -2 and subtracting 0? No. So don't we literally just have -2 over 5? But we have it twice, right? With a multiplicity of 2. So this would be one real solution. So that's when we have one real solution, it's because our discriminant was 0. We had one real solution with a multiplicity of 2. Yeah. Yeah, well, so that would be like if it comes, touchdown, and bounces back up, right? Bounce means, right, look, multiplicity of 2. Does that make sense? Otherwise, it would have crossed twice, boom, boom, different answer. Yeah, great question. Okay, so you don't have to memorize this, just think about it. That's way easier than trying to memorize it. Hopefully that made sense. Here we go. All of my examples are off your worksheet. Number 17. If I said to you, use the discriminant to give me what kind and how many solutions you're going to have, you could go through the whole process of solving the whole thing and then look and say, oh, I have two imaginary solutions. But why do all the extra work? Do you see what I'm saying? I don't want to know the actual solutions. I want to know what kind and how many. So first of all, we'd say all quadratics have 2. So let's just write 2 here. Oh, let's just go for the discriminant. Sorry, I'm not going to write that down. Here we go. We know we're going to have 2, but I'd rather write it out pretty. So I'm going to just say, well, what kind of solutions am I going to have here? Let's discriminate against the problem using the discriminant. Remember, it's what's under the square root, because that's what's going to discriminate against if we have imaginary, irrational, real. Here we go. So we would say our discriminant is b squared minus 4 times a times c. So let's calculate this one's discriminant. So 5 squared minus 4 times 1 times 8. And remember, what's the one rule I have in this class when doing quadratic formula? Just type that in exactly as you see it. Don't try to do it in pieces on your own. Just type it in exactly as you see it. What is the discriminant? -7. Now, that is the discriminant, but once again, the discriminant is under the square root. I'm just writing this up on the side. My discriminant is -7, but it's going to be square root of -7. So how many solutions and what kind will we have? Yep, it was negative, so it was negative under a square root, so 2 imaginary. Do you see how much easier that is than trying to memorize it? Just thinking about it is much easier than trying to memorize it. All good? Do another one. Look at number 18. What kind and how many solutions are we going to have? Let's calculate the discriminant. So you do negative 5 squared using parentheses, minus 4 times a times c. And my discriminant, the part that's under the square root, is, you should all hurry and type it in. The quicker you are, the less homework. You got 3? Does everybody else get 3? No, so your discriminant's 9. So don't confuse that with what is not the discriminant. Okay, so our discriminant is 9, right? So now you'd go out to the side and say, well, the discriminant's what's under the square root, right? That's where you got the 3. But once again, I just don't want you to get this backwards, so then you might not actually write square root of 3. Does that make sense? Okay, so square root of 9 is 3. So think about it. Don't we have something, but we're not going to actually calculate the something, plus and minus 3 over something. So how many solutions are we going to have? 2 fractional solutions. So that would be 2 rational solutions. Does everybody see? I could actually find this something. I could find the actual solution. But why do the extra work? Do you get why I just put a star there? Because I don't want to actually find out x equals negative b plus or minus the square root of b squared minus 4c all over 2a. Do you see why I'm not writing it? Some of you look very confused. You gotta tell the truth. Okay, so we would have 2 irrational. No, they're rational, aren't they? They're fractional, so they're rational. So we'd say 2 rational. And then if they're rational or irrational, they're real. They still cross the x-axis. 2 rational, real. Okay, let's do number 19. I don't care what the actual solutions are. I just want to know how many and what kind. So here we go. Let's discriminate against the problem using the discriminant. 12 squared minus 4 times negative 9 times negative 4. B squared minus 4 times a times c. So our discriminant is 0. Now once again, under our square root then was a 0. The square root of 0 is, so we have something plus and minus 0 over something. How many solutions and what kind? Well, something plus 0 and something minus 0 is the same something, isn't it? So this would be 1 real rational solution. 1 real, and rational means it can be written as a fraction, and it would be. 1 real rational solution. And it would obviously have a multiplicity of 2. With multiplicity of 2. That's being way exact, but that's not a bad thing. Okay, a couple more. Now, once again, if you forgot this for the test, don't let discriminant throw you off. Solve the whole dang thing and then look at your solutions. Does that make sense? If you solve all the way and you get 2i and negative 2i, you'd say 2 imaginary solutions. You see, but that's just extra work. Okay, cool. But like I said, if you were desperate, it'd be worth it to get them right. Here we go. So let's do this one. Oh, before you can solve the quadratic, it has to be equal to 0. So subtract x, subtract 2. A lot of people want to bring 6x squared over this way because that's only one step, but I highly recommend keeping your a positive. It's just nicer. You wouldn't be wrong, but. So we have 6x squared minus x minus 2 equals 0 now. Okay, discriminant. Because I want to know what type of solution. B squared minus 4 times a times c. Yep, 49. Our discriminant is 49. So you'd say to yourself, well, the discriminant is under the square root. Square root of 49 is 7. So we have something plus and minus 7 over something else. Isn't that 2 rational real? Those are fractions, right? 2 rational real. Or 2 real rational. I don't care the order. Okay, last example, then I'll let you finish up that front page on your own. First of all, we need to make it equal to 0 before we can actually solve this or go for the discriminant. So I'm going to bring these over this way. Just because, once again, I like to keep my leading term positive if possible. So we have 0 equals 3x squared minus 5x minus 1. How many and what type of solutions? Let's just use our discriminant. B squared minus 4 times a times c. Discriminant is 37. So then you'd say to yourself, well, that's really under the square root. Is that going to break down? No, so we're going to still have square roots in our answer. That's irrational. We'd say 2 irrational, still real, still crosses the x-axis. It's just at a decimal that can't be written as a fraction. 2 irrational real solutions. That, I swear to you, is so much easier than trying to memorize, oh, it's this and this and this and this. Just think about it, because then you have enough to remember for the test. Okay. Ready, go. Do the front, 17 through 28. Okay, what we're learning today is we're going to learn how to solve by factoring polynomials that we have not learned how to factor before. Now, I do want to spend a minute reviewing once again the methods that we do know, because you will be tested on it again. So redeem yourself if you failed this on the test. So everybody, look at these first ones. Before we learn the new methods, let's review the old methods. How would I factor number 5? This is off your review. Off that. Quick factoring. It's a quadratic. We're using the method of solving by factoring, the quadratic. Well, multiplies to be negative 27 and adds up to be negative 6. Negative 9 times 3. Look, it does really work in both places. And once again, I can quick factor. So the quadratic factors to be x minus 9, x plus 3. Please get in the habit of not being lazy and skipping and thinking your brain is smarter than everybody else's, so I'm just going to skip steps. Just write it out, because in the future, we have to be able to write out the factors anyway. So now we can solve x equals 9 and x equals negative 3. It's the people who don't skip steps that end up getting the hundreds on the test. Or the people who do are the ones who miss little errors that add up. Here we go. What method is number 6? We don't have 4 terms. Good thought, though. This one's factor by greatest common factor, so we'll pull out an n. Divide by n, divide by n, divide by n. Now guess what some poor unfortunate souls did on the test? They divided by n, and they pretended like the n disappeared into thin air. And they never wrote it again. That's a problem, because then you're missing that for a solution. So left inside is n squared plus 17n plus 72. Now remember, you'd say I have a linear, I have a quadratic. Now I can solve. I'm going to keep factoring that quadratic. Well, multiplies to be 72 and adds up to be 17. Perfect. And once again, it really works in both cases. We can quick factor because our leading term's 1. So this piece factors to be n plus 9 and n plus 8. Now, once again, don't forget, ding, 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 that n. Now we have it factored completely, we can solve. Set each of those equal to 0 and solve. So we get n equals 0, negative 9, and n equals negative 8. And once again, we should always check. Degree 3, 3 solutions. Degree 2, 2 solutions. We're doing good. Okay, what method here? Hey, you guys go for it, I'm going to go for it. And then you can check with mine up here. You guys go for it. We have about 10 minutes till lunch, so let's get this page done here. Okay, I factored mine. See if your factors match up when you're done. I'm not done solving. I've just factored mine. I'm just waiting for you to get to the factored point. I'm going to wait till everyone gets to the same page. Okay, you solve, I'll solve. Good, that's fine with me. So now we can set each of those equal to 0 and solve. Are we getting the same answers? Yep. Set each of those equal to 0 and solve. Now we spent a whole day understanding that that is not considered a simplified answer. I need to simplify my answers. Can I pull out a 2? B is equal to plus and minus 2 root 2. And it's degree 3, 1, 2, 3 solution. So I'm not missing anything. All good? Okay, so what I'm going to have you do is take a minute and finish up that page before lunch as much as possible. Now, once again, make sure you write all your final answers in the most simplified format. And you can talk and help each other out. So not just do 2 and 7, do all on that front page. I guess it would be 1 through 10. 1 through 10. Okay, because I feel like I did give you more time than I needed to on the other piece. We're a little behind, so we'll catch up. Okay, everybody. So look at this. Number 9 is on the back. It is just a few down. We're skipping 1 through 8 for a second. So look at number 9. Look how if I said to you, find all the solutions, right now we would not know how to factor this one by any method we know. So look, it's not 4 terms, so we don't factor by grouping. There's not a greatest common factor. Does everybody see? So we would not know how to solve this one quite yet. Now, here's the thing, though. What I want you to notice about this, doesn't it look pretty similar to this? They almost look identical. Look, positive 4 at the end. Look, negative 5x squared and negative 5x. X to the 4th and x squared. So this is what, if you have x to the 4th, x squared constant, this is what's called quadratic in form. It almost looks like a quadratic. It is a quadratic in form. So what we do is we rewrite this in a different way so that we can more easily see how to factor it. And we do this by factoring by what I call a U substitution. So let me show you something. Notice I said we're going to have x squared equal u. Okay, I'm making a substitution here. Now I want you to notice that x to the 4th, I can rewrite as x squared, can't I? And then we have minus 5x squared, and then plus 4. Now look, now in my equation I have an x squared, I have an x squared. So what we're going to do is we're going to replace all x squareds with a u. So let's rewrite this. This becomes u. So we have u squared minus any x squared becomes a u. So minus 5u plus 4. Now looking at this, do we know how to factor a quadratic? Yeah. So now we're going to go ahead and factor this quadratic. Now yes, it does matter that we have u's instead of x's, but we're going to then, in a minute, reinsert x squared back in after we factored it. Okay, so let's factor this. Yep. No, look, this was x squared squared, so only x squared becomes a u. So do you see how that's a u and a u? Okay, awesome. Here we go. Let's factor this. Well, multiplies to be 4 and adds up to be negative 5. Negative 1 and negative 4. Very good. Now, can I quick factor this u? This u quadratic, yep. So u minus 1 times u minus 4. We just factored this. Now what we're going to say to ourselves is our original polynomial wasn't u's. It was actually x's. So we're going to re-plug in what we substituted in u for. So instead of the u, we really factored this to be x squared minus 1 times x squared minus 4. So now we factored the original polynomial. And now we can solve. Right? We factored it, now we can solve. So since they're both quadratic, we can continue to solve. Now we could actually factor that more. That's one way of doing it. Or couldn't we just set each equal to 0 and solve? Yeah. Which way do you prefer? Okay, x squared minus 1 equals 0. X squared minus 4 equals 0. Solve for x in each case. So I'll add 1. X squared equals 1. Square root both sides. What? Don't say the square root of 1. We need to understand the square root of 1 is just 1, guys. So x is equal to, okay, there's 2 of our solutions. We'll add 4. X squared equals 4. We'll square root both sides. X is equal to plus and minus 2. Now, once again, the original polynomial was degree 4. We should have 4 solutions, and we do. So we just took and rewrote this in a different form using a substitution. You do this a lot in calculus, so some of you will need to do that for your majors in college. So this is good to see. Okay, here we go. Look at this one. Is it quadratic in form? X fourth, x squared constant. Is it quadratic in form? Yes. So we could say to ourselves, isn't this really technically x squared squared minus 12x squared plus 11? Now, once again, we're going to say we're going to let u equal x squared. Anywhere I see an x squared, I'm putting in a u. So this becomes a u, and this becomes a u. So let's rewrite what we have. U squared minus 12u plus 11 equals 0. Let's factor this, because now it's just a quadratic. Is anyone lost? Well, multiplies to be 11 and adds up to be negative 12. Perfect. So this quick factors to be u minus 1 and u minus 11. Don't accidentally solve for u. We're not solving for u. We need x's. So say, okay, actually, it really factored. We put in x squared minus 1, and x squared minus 11. We factored it. Now we can solve. Set each of those equal to 0 and solve. Yeah, you'll need another piece of paper for sure. So we add 1. So x is equal to plus and minus 1 again. Add 11. Square root. So x is equal to plus and minus root 11, which doesn't break down. And once again, it's degree 4, so we need 4 solutions. Yes. Okay. All good? Now let's go a little bit quicker. Let me do one more. Let's just do one more. Let's go a little quicker. So we have degree 4, degree 2, constant. It's quadratic in form. Let's factor by u substitution. Are you comfortable enough at this point to just say this is going to become u squared? U squared minus 10u plus 16, as long as u equals x squared, that is. So keep in mind, though, this would not work for like x fourth and then an x cubed. It wouldn't work. You see why? Then we wouldn't be able to substitute in a u right here. You get what I'm saying? Okay, cool. So now let's factor this. What multiplies to be 16 and adds up to be negative 10, 8 times 2, and negative again, right? So this factors to be u minus 8, u minus 2. But really, we weren't dealing with u's, we were dealing with x squared, so it really factored to be x squared minus 8 and x squared minus 2. And now we can solve for x. So make sure, once again, you break down square root of 8, pull out groups of 2. Do you know what I'm talking about? So what do we pull out? 2 times 4, and then 2 and 2. So when we pull out a 2? 2 root 2. So we have plus and minus 2 root 2. And then right here we'll add 2. X squared equals 2, square root, square root. So x is equal to plus and minus root 2. Degree 4, we should have 4 solutions, and we do. Yes. Yes, we'll always simplify our answers. Perfect. Okay, everybody. So yes, good question. You will simplify your answers. Okay, I don't think you need more examples. Do 9 through 16. Go, go, go. 27. Okay, look, isn't it still quadratic in form? Degree 4, degree 2, constant. Hey, let's rewrite this as a u substitution. Let u equal x squared. So this is going to become, you tell me, 2u squared minus 26. U minus 28 equals 0. Now there's 2 ways to factor this one. We could do what multiplies to be a times c and do long factoring. Or we could first recognize we can pull out a 2, can't we? I'd rather do that, pull out a 2, and then be able to quick factor. Sometimes you can do that, sometimes you won't be able to because it won't be a greatest common factor. So then left is u squared minus 13u minus 14. Now you'd say to yourself, okay, cool, now I got to keep factoring this. What multiplies to be negative 14 and adds up to be negative 13. Negative 14 and 1. You're right. We can now quick factor. So this factors to be u plus 1 times u minus 14. Now don't forget, we also had a 2. So what we actually have is 2 and then x squared plus 1 and then x squared minus 14. Now what would have happened is, if you would have done long factoring, this is what you would have got. You would have got 2x squared plus 2 times x squared minus 14. Isn't that what we actually have? Same thing? Yeah, it's just now, instead of pulling out the 2 from the beginning, can't you pull out a 2 now? So does that make sense? It's just, when do you want to divide out the 2? Right here or back there? Back there is way quicker, right? Okay, cool. So let's continue to solve. Now, I need to be very clear. Let's continue to solve. Will this 2 have any effect on my solutions? No, because there's no variable here. If this was 2x, that would be a 0 as a solution, but it's just 2. So it doesn't affect my solution. So we'll set x squared plus 1 equal to 0, set x squared minus 14 equal to 0, and solve for x minus 1. X squared equals negative 1. Square root both sides. Root cancels out with power. X is equal to? You're right. Plus and minus I. Way to go. And right here, we'll add 14. Square root both sides. The square root of 14 simplified. Good. So we have plus and minus root 14. Check. Degree 4. We have 4 solutions. Now watch, I promise you that 2 really won't affect it. Let's pretend we have the 2 left inside. Let's solve real quick. Watch, just watch me do it. So wouldn't we just subtract 2? 2x squared equals negative 2. Divide by 2. X squared equals negative 1. Square root. X is equal to plus and minus I. So did I prove to you now that the 2 really did not affect? You see? It's just, when do we divide out the 2? At the beginning or in the math? Does that make sense, everyone? Cool. Perfect. Okay, cool. Okay, go to 31. Once again, before you can solve a polynomial, it has to be equal to 0. Instead of bringing x to the 5th over this way, that would make it negative. I like to keep my leading term positive. So I'm going to subtract x cubed, subtract 12x from both sides. Now don't start doing weird mathy things that you know better. I can't combine things that are not like terms. So this is x to the 5th minus x cubed minus 12x equals 0. I want to point something out. This is not of the form x fourth, x squared constant. So we would not use the u substitution right here. We should be pulling out an x. You're right. So our first step is pull out an x. We wouldn't want to because this isn't negative in front. You could, but you wouldn't want to. So we pull out x, and then left is x to the 4th minus x squared minus 12. Now, dang nabbit, continue factoring the inside. It will be a dang u substitution. That's okay, because those are quick. It does matter, so we'll just have to remember that that's a factor in the end. You're right. It does matter. Good point. So what we're going to do right now is say I'm going to continue to factor this by u substitution. U is x squared, so this is really u squared minus u minus 12. Let's factor this. What multiplies to be negative 12 and adds up to be negative 1. Negative 4 and 3. Can't I quick factor my u? So this quick factors to be u minus 4 and u plus 3. And you'd say, but really, that's x squared minus 4 and x squared plus 3. And then you'd say, that's great, and we can't forget about that x, right? So boom, and now I factored it completely, and now I can solve. So we'll set each of those equal to 0 and solve. So x equals 0. X squared minus 4 equals 0. X squared plus 3 equals 0. Solve for x. X equals 0. Already solved for. Add 4. Square root it. Let's do it in our head. Plus and minus 2. And then subtract 3. I'm not going to do this one in my head. X squared equals negative 3. Next step. So what am I going to get? X. I3? Perfect. You're right, because there is a difference. Perfect. Let's count. What was the original degree? Look back at the top. Degree 5. 1, 2, 3, 4, 5. I've got them all. Sweet. Continue. Continue. What I want you to do is take a couple minutes and continue the problems. Still 9 through 16, then go down to the bottom and do 26 through 32. Go. Go, go, go. Here we go. So everybody, now looking at this method, what this is, everybody looking, do you see how this is not a U substitution? It's not factoring by grouping. There's no greatest common factor. Let me show you what people want to do when if I said to you solve, want to know what people like to do? They subtract 64 and then cube root it. Cube roots don't have plus and minuses. Okay, that's great, but then how many solutions did you just find? 1. How many solutions should you have? 3. That's a very common mistake. So what you've got to do is you've got to factor this out correctly so that you can actually find all of the solutions. Okay, so here's how you'll do it. So I want you to notice something. We have 2 perfect cubes. What I mean by that is if I cube root them, they come out a perfect number. What's the cube root of x cubed? X. What's the cube root of 64? Everybody learn on your calculators. Hit math. Hit math. Go down to cube root. Hit math. Go down to cube root. Type in 64. 4. Right. So do you see how it came out perfect? Those are 2 perfect cubes because x cubed equals x cubed and 4 cubed equals 64. Now look right here. If these 2 perfect cubes, let's take the cube root here. Take the cube root here. What's the cube root of 8? 2. Now think about it. The cube root means what cubed equals me? 2 cubed equals 8. Does everybody see why the cube root of 8 is 2? Okay, and then right here, wouldn't this be x? Cube root of 27 is 3. You see how that came out perfect? So what we have is the sum and the difference of 2 perfect cubes. 1, 2, 2 perfect cubes. So what happens is they factor to be this format. They factor to be this. Okay, ready? Write that down. Now a lot of teachers, so if you have 2 perfect cubes, it factors to be this. If you have 2 perfect cubes, it factors to be this. It looks harder than it is because I'm going to teach you a trick on how to remember this. Yes, now that's a fun fact for you. A lot of teachers just say memorize the format and put it in that format. I'm going to teach you a trick. I don't have it memorized. I teach you a trick on how to remember that so that you don't have to memorize it. So writing that down. This is how you can remember it instead. Okay, so this is considered the front term and the back term. Does that make sense? I mean, it's just common sense. Front, back. That's what I'm going to call the front, the back. So watch how you can rewrite this. Well, isn't this in front? Yeah. Okay. So it's not, don't overthink it. I'm just making it basic here. So what you're going to do is cube root the front thing and cube root the back thing, not including the sign. So in the front thing, won't we get A? In the back thing, won't we get B? So now look what happens. I throw in parentheses and this sign drops straight down. Do you see how I really got that? Now watch what I do next. Here's where the trick starts. So now to get this next part, everybody listening, it's kind of dumb, but it really helps. So the song starts. You do the front with the front, then the front with the back, then the back with the back. So let me do that one more time. The front with the front, then the front with the back, then the back with the back. So watch. So watch. You take so watch where all that helps. Front and the front. What's A times A? And then the front times the back. Then the back times the back. Does everybody see how that works? And then, this is how the signs work. So everybody listening, this sign drops straight down. The next sign that comes after that is always opposite. And then this sign's always plus. This sign's always plus. Okay, so watch, let's do the same thing on the back. Cube root the front thing, cube root the back thing. Isn't my front thing A, my back thing B? You put parentheses, this sign drops straight down. You see? Now you do the front times the front. A squared. Front times the back, not including the negative. Front times the back is AB, and then the back times the back is B squared. Now if this sign's negative, the next sign's opposite. This sign's always plus. Okay? Let's put it to use. Here we go. Number 2. Here we go. Here we go. Okay, everybody, here we go. So you say, are these 2 perfect cubes? Well, let's check. Cube root that. Cube root that. What's my front thing? What's my back thing? Cube root of 64. 4. Okay, let's start our little thingy-majiggy. Put your parentheses in. Okay, focus. Here we go. Now we're going to do the front times the front. X times X. Yep. Now the front times the back. 4x. No putting in sign. Then the back times the back. 4 squared, which is 16. And now we'll go ahead and put in our signs. If this one's plus, this one's plus, the next one's opposite. The next one's always plus. Now look, I factored it down to linear, quadratic. I can solve this. There we go. So it really wasn't as bad as it looked, is it? Okay, here we go. So we have x equals -4. Okay, next one. This is not going to factor. This is not going to factor. Perfect cubes have 3 solutions, but 2 of them will be imaginary. If it's 2 perfect cubes, that is. Okay? So you could try. 1 multiplies to be 16, adds up to be -4. Nothing. So quadratic formula. Here we go. X equals -b. So +4 plus and minus the square root of b squared -4 times a times c all over 2 times a. So we would, what's my next step? X is equal to 4 plus and minus. Remember, Miss Christensen says you have to type that into your calculator exactly as you see it. Go. Type that into your calculator exactly as you see it. Go. Quicker the better. Yeah, that's right. Now, isn't this the step? Once again, I'm not going to spend a lot of time going over how to simplify this correctly. That's why we spent extra time at the beginning of the year. Go off to the side. Break down -48. 8 times 6, 4 and 2, 2 and 2, 3 and 2, right? Aren't I pulling out groups of 2, everybody? 2 and a 2 we can pull out. That's got to stay, and we're pulling out an I. So 4i√3, so rewrite it again. We have x is equal to 4 plus and minus 4i√3 all over 2. Do those simplify. So, right? Yeah, and once again, I'm not going to spend extra time on that because we should be good at this point. I don't know. Okay, here we go. Chat, was it degree 3? 3 solutions? Yes. Here we go. Next one. Let's do it again. How is it not? Why do I make my secondary 2 students split it up instead of write it together? Because they asked that question, which is extremely obvious. Do you see why we have 2 solutions right there? That's why I force my little students to split them up usually. Oh, okay. It wasn't that much confusing you. Okay, gotcha. Yeah, I'm like, wait. Okay, number 1. Here we go. Let's do it again. You say, are these 2 perfect cubes? Cube root the front thing, cube root the back thing. 2x, what's the back thing? 3. Let's go for it. Put in your parentheses. Here we go. Everybody focusing. The front times the front. 2x times 2x. No, 2x times 2x. Okay. Then the front with the back. Then the back times the back. Now let's put in our signs. If this is minus, this is no. Still minus. The next sign is, and the end's always plus. Okay. Now we look. We factored it to be linear, quadratic. We can solve. Here we go. Solve for x. There's one of our solutions and quadratic formula. But I didn't give you that many of these. Then remember we typed just that in. Here we go. So simplifying the square root part. So then 9 and 12, 3 and 3, 4 and 3, 2 and 2. So I'll pull out a 3, I'll pull out a 2, I'll pull out an I. 6, I. Okay, so we have x is equal to -6 plus and minus 6i root 3 all over 8. Can those three simplify? Yep. What do they all divide by? So this divides by 2 and becomes a 3. Divides by 2 and becomes a 3. Divides by 2 and becomes a 4. So I also have x is equal to -3 plus and minus 3i root 3 all over 4. We have degree 3. We have 3 solutions. So yeah, secondary, that's the one fun fact. Secondary 3, our problems are long and much is not like secondary 2 where it's like 2 plus 2 equals 4. Yeah, exactly. Okay, look at number 3. This is my last example here. Let's go quickly. Guys, focus. We only have like 6 minutes left, so you need to focus. Do you see how if I try to cube root this, that's a cube root of 2 is a problemo. Yeah. That's a problem. It doesn't come out a whole number. Do you see what I'm saying? So that doesn't work. But so what we should have done first was pull out a greatest common factor. Don't they both divide by 2? Pull out a 2, divide by 2, divide by 2. Left is x squared plus 27. Now you'd say, I need to continue to factor this. Oh, that's the factoring by the 2 perfect cubes, right? The method we just learned. So what I'm going to do, cube root the front thing. Cube root the back thing. The front thing is x. The back thing is 3. So then are we going to put our parentheses? Front times the front, x squared. Front times the back, 3x. Back times the back is 9. This must be the same as the original sign. Next times negative, next times plus. And now don't we have a 2 out here? Now set each of these equal to 0 and solve. Is this 2 going to... Nope. Okay, so we have x plus 3 equals 0. And then we have x squared minus 3x plus 9 equals 0. Solve. X equals -3. Quadratic formula. Okay? You could try, but it doesn't work. 1 multiplies to be 9 and adds up to be 3. Nothing. -3. Well, 1 times 9, 3 times 3. Do any of those add up to be -3? No, quadratic formula. Yep. Okay. So you have the rest of the time, which is not that much. Here's one more thing to note. Look at this one. I just want to see it. Let's just factor this one at least together. Cube root the front thing, cube root the back thing. What is the cube root of the front thing? 3x. What's the cube root of the back thing? 1. So now we can put this in. Front times the front, 3x times 3x. Front times the back times the back. And then this is plus, this is negative, this is plus. And now we can solve. So don't let 1 throw you off. That's why I was showing you this one. Is because sometimes people let 1 throw them off, but don't. No different, right? Okay, so what I want you to do is finish the worksheet and understand. Remember how to do the story problems. With story problems, can't we solve by calculator? These aren't going to be factoring ones. They're going to be volume ones that we've gone over so much in here. It's just reviewing because you might see it on the upcoming test again. So don't let the story problems throw you off. Don't you just set up a true statement and then solve by calculator. Okay, cool. All right, cool. Finish the worksheet. You got it. It's really not as much as it looks because they go pretty quick.